Okay, guys, this is notes on 12.4, 12.5 volume of prisms, cylinders, pyramids, and cones. 155 in your notes, 5/11, 2020. So volume, remember, is always cubic in nature. So inches cubed, centimeters cubed, feet cubed, yards cubed, millimeters cubed, everything cubed. All right, that's volume. Length times width times height. You can think of that idea. But here are all the volume formulas, and I want to go over them. So I'm going to zoom in. So the volume of a prism is big B times H. Big B means the base area. So it's that base area times the height that fills up the prism. So as water fills into that prism, the base fills up first, and then it goes straight up to the top. That's volume. It's like if you had whatever. I'm thinking of something like something to drink, but no. Okay, the cylinder, as like a cup, is the base area times height. The base area, if you fill that up, the base area is a circle, so it's the area of the circle, pi r squared, times the height. As it fills up, it fills straight up. And then a pyramid and cones. So think of prisms and cylinders being the same, pyramids and cones being the same, where this was base area times height, base area times height. This base can be any, could be a triangle, could be, in this case, a pentagon, could be a trapezoidal base prism, whatever, a square base prism, but it's the base area times height. This base area of a cylinder is always a circle, so pi r squared times height. A pyramid and cone is 1/3 base area times height. Okay, because as you fill this up, pyramid, the base gets smaller. So they did quite a few experiments on this, and they came up with the value would be about 1/3 of the figure when you fill it up, compared to a pyramid or a prism, excuse me, which was square based. So as you look at it, the height is this height in the middle, not the slant height, because the slant height would be a height, and I'm going to show you one on the angle there. So it's a little bit different, but you need the height in the middle of the pyramid or the height in the middle of the cone, not the slant height, okay? So this is 1/3 the base area, so you'd find the base area, whatever that base is, times the height. 1/3 base area times height for the pyramid, 1/3 base area. Now in a cone, the base area is a circle. But as that fills up, you can see that the circle is getting smaller, so that's why you have to have the 1/3 in there. 1/3 pi r squared, just like the cylinder, but it's 1/3 pi r squared times the height, and the height is in the middle. The height of a cylinder, as you can see, is the same as the height of the outside part. Okay, so a few examples. So I'm breaking it up into 4 different examples. So I got pyramids, and I'm going to back this out a little bit. I got prisms, cylinders, pyramids, and cones. So I got 4 different areas. So I'm going to use my calculator. So prism. So let's say prisms, they can either be right or oblique. Oblique means they're slanted off to the side. So I've drawn them all out. So here's the right prism. The side here is 12, 10, and then this height here is 11. So the base is a triangle. So you know it's 1/2 times the base times the height. So 1/2, 12 times 10 times this height here is 11 of the prism. So you get 660. Remember, this is centimeters, so your units are centimeters cubed. Whereas oblique, it's kind of like on an angle. So this height here is 5.1 feet. So you find the base area first. Now, they gave you the base area in this one. Sometimes they don't give you the base area. Sometimes you're going to have to find it like you would with an apothem or whatever, using apothem or using a variety of different formulas to find the surface, okay, of the base. So in this case, the base area is 11.4, so this is easy. Base area is 11.4 times 5.1 is 58.14. Now, if you wanted to round it to 1 place value, 1/10 place value, you'd round it to 58.1, because that 4 is not 5 or more. Remember, it's cubic in nature, so cubic feet. Okay, moving down, cylinder. So cylinder, I'm going to move down here. I guess I really didn't need to show you anything on the calculator, because you guys all know how to do that. So in the cylinder, I'd made one that's on its side. So, and I gave you the radius, and it's right, because it doesn't go on an angle. So the base area is pi r squared, so pi times 5 squared times the height, 18. Very simple, 1,413.7 cubic yards. Remember, cubic. This one's oblique, so it's on a slant. Here's your height. I gave you the diameter this time. You had to cut the diameter in half to get the radius, so 7.5 squared. So pi times 7.5 squared times 15.2. Okay, if you're watching this, there's two problems with this problem. If you're watching this for 2 points extra credit on your homework, there's two things that are wrong, okay, in this problem. So can you see that the word oblique is spelled wrong? O-B, this is supposed to be L. So you got to, on your homework, you got to, over to the right, you got to tell me that you spelled it wrong. I spelled wrong, and there's no units on this one. So there's your extra credit within something. If you don't watch the video, you don't get the extra credit. So you got to tell me it's the cylinder's second example of the cylinder. Oblique is spelled wrong, and the units aren't here. The units should be millimeters cubed. So you got to write oblique, O-B-L. Should be an L there, right there. And this part should be millimeters cubed, right here. So you got to tell me that was missing in order to get your 2 points extra credit. Where's Waldo? There we go. You peoples, I want to keep you in line. All right, now this pyramid's a little bit different. The pyramid is given 9.2, and this is actually one of your problems, the first problem on your volume formula problems. So this one, it says 9.2, 9.2, so that's a square base pyramid. So when I say, yeah, I think I said pyramid. And this height here is 13. That is not the height. That is the side of the pyramid. Here's the problem with that. We have to do two Pythagorean theorems, because in order to get this height, which we need in orange, which is the volume height, that's we need base area, 1/3 base area times the height. We have to do a Pythagorean theorem to get this L, this slant height. That's the height of the face of the pyramid. Then we have to use that to find the height of the entire pyramid, the altitude, in other words. So we would go L, 4.6, which is half of 9.2, and then 13. We work the Pythagorean theorem out, get 12.2 for L, which is your slant height. Then take that triangle right there. Now 4.6 is the same distance across as 4.6 because it's a square. So that's 4.6. That height is 12.2, and then the height here is your altitude, what you're trying to find. So you work that one out, Pythagorean theorem, and you get 11.3. Now you can find the volume as 1/3 base area, which is 9.2 times 9.2 times your height or your altitude, 11.3, and work that out, and you get 318.8 cubic yards. Okay, second example is an oblique pyramid. So I drew it as best I could, slanted off to the right. So it's 1/3 base area, which is your 4 times 4, 16, times your height, which I already gave you, is 6. Easy problem, 32 cubic feet. And the last is cones. So I gave you two easy ones. Both of them have the radius. Both of them have the height. So it's 1/3 pi r squared, because that's the area of the base, times your height. Put in your radius. Work it all out, 452.4 inches cubed. And this one, 1/3 pi r squared times h. 1/3 pi times 4 squared times 20, 335.1 meters cubed, because you're dealing with meters. All right, that's it for your surface area and volume of prisms, cylinders, pyramids, and cones. I'm doing many different videos. Have a great day.